Let's talk about variable stars, specifically a type of variable star called a Cepheid. Variable stars are stars that fluctuate in their brightness or luminosity. All stars change in brightness over time. Our sun, for example, goes through an 11-year cycle with increased sunspots and surface activity when it's hotter. But we can't see the sun's changing brightness with our naked eye. It takes high-tech measurements to detect this. Variable stars are different. Observers can easily see changes in stars' brightness with the naked eye. Some variable stars can even change in brightness by up to 20 magnitudes. Cepheids are a specific type of variable star called a pulsating variable. Cepheids vary in brightness over a pulsation period. Take a look at this light curve. Light curves are graphs of the magnitude of brightness of a star over time. The peak shows the star's maximum brightness, and the valley shows the minimum. Astronomers use observations made by professionals and amateurs alike to gather as many data points as possible when plotting these light curves. The pulsation period, or phase, is the time it takes for a variable star to complete one cycle. Now, why does this matter? Why are Cepheids so important? Well, an amazing discovery was made by Harvard computer and astronomer Henrietta Leavitt when she was studying Cepheid variable stars in the small Magellanic cloud. Leavitt discovered a relationship between the period and luminosity of a Cepheid. Brighter stars had longer periods, and fainter stars had shorter periods. This discovery of the period-luminosity relationship allowed astronomers to measure distances across the universe. Prior to this discovery, astronomers measured distance by the use of parallax. If you hold your thumb in front of your face and alternate between keeping one eye open and one eye closed, it will appear as if your thumb is moving back and forth. This is called parallax. The same principle can be applied when measuring distant objects in space. Astronomers can measure the star's position in space from two different perspectives, and then calculate the apparent motion, which is called stellar parallax. However, using stellar parallax to measure distance has limitations. We cannot use parallax to determine extremely far-off objects because parallax angles smaller than 0.01 arcseconds are very difficult to measure from Earth. This limited our measurements of the objects in the universe to 100 parsecs, or only 326 light-years. This is why Leavitt's discovery was so important. By measuring the period of a Cepheid variable star, we intrinsically know its absolute magnitude, how bright it really is, not how bright it appears. With this knowledge of absolute magnitude, we can compare it to the star's apparent brightness to figure out its distance. Leavitt's single discovery has led astronomers to amazing finds, one of the most impacting of which is the ability to measure distances that were previously impossible to measure using parallax. We have expanded our measurements of the observable universe from hundreds of light years to billions. Continued research on variable stars is still important today, and anyone can participate. Professionals actually depend upon the help of amateur astronomers in observing and recording the vast expanse of our night sky.